cover the mock test quiz 2 today?
No, today is the revision session for 7 and 8. So I will cover 7, 8 and some of the questions, and then I will pick if you have some doubt. Okay.
Okay, ma'am. Thank you, ma'am.
Yeah.
Hello, ma'am. I
Yeah.
have questions regarding the grading system. So, in the final score, will the quiz 1 and quiz 2 both will be both have an effect on the marks, or maximum marks from one?
Yeah.
Yes, ma'am. I'm asking you if quiz 1 and quiz 2, like both the exams will have an effect on the grading system, or rather would it be the maximum marks of the two that would have the effect, like due for the final?
No. Quiz 1, quiz 2, both we will conclude, and I guess there will be 10 marks from your graded assignment, which is the best of 10 maybe.
That is also in the, like, there's also written over there key maximum marks of both the one of the quizzes will be taken for final grading.
Okay, is it written in the portal?
Yeah, it's like to be eligible
Then
also.
then
No, madam. It is not like that. You have 10 for graded assignments, 20 for quiz 1, 30 for quiz 2, and 40% for interim. In case,
yeah.
and there is one more option, or one more say is there. What is that is? This 20% of quiz 1 plus 20%, 30% of quiz 2 is taken as one number. Again, you take one more as 20% of 30%, 20% of quiz 1, quiz 2, whichever is maximum. That is, in case you miss either quiz 1 or quiz 2, then that formula has to be used. The maximum will be taken. You understood?
If I have another exam on Monday and if I won't be able to give quiz 2, so the maximum marks would be taken for.
Yeah, you lose 10% of that marks. So 20 plus 30 is 50%. So quiz 1 is 20.
In the graded marks, it's like I've taken a screenshot. Can I like share it?
40%. You will get instead of 50, you will get only 40% of the maximum.
Can I share the photo here, like what I've like taken?
Madam has to
Yeah,
answer that.
yeah, sure, you can share it.
Okay. 1 second.
Hello. Hello, ma'am.
Hello. Yes.
Syllabus is week 1 to week 8, right? Right?
No. Syllabus is from 5 to 8.
Oh, okay.
Yeah.
Okay.
In all subjects, ma'am, notification is coming for only stats 1.
Which notification?
Ma'am, I got the email for status 1 that the syllabus of stats 1 is week 5 to week 8, not for the other subject.
No. For maths 1 also, the syllabus for week quiz 2 is from 5 to 8 week. So it should be mentioned in the portal, what I guess. But if you're confused, then yeah, it is definitely from 5 to 8. Okay, not from 1.
How many questions we are supposed to expect?
Shared the photo in the chat box.
Yeah. Yeah. So what is your doubt? What did you say, just?
That the maximum marks will be taken of any from one of the quizzes. Like it's written over there, key 0.11 GAA plus max 0.6 final marks, or 20% of quiz 1 or quiz 2, anyone, like maximum of anyone.
So you get 0.6 plus 0.2 is 0.8, 0.1 is 90% only it is coming here, no?
Okay, in that manner you are saying.
Yeah. A maximum of in between the after quiz 2 close bracket you have one comma. So 0.6f plus 0.2 max of quiz 1 quiz 2 is one formula, or you take 40% of final, 20 for quiz 1 and 30 for quiz 2. That is you will get 90. 40 plus 20 plus 30 is 90, but 60 plus 20 is 80. So you lose 10 marks if you don't attend.
Okay. Okay. Thank you. I got it.
Okay.
And is there any criteria that for quiz 1 mark should be greater than 40%?
Nothing like that, madam. T, finally, you have to see T equal to whatever your formula is coming. You have to get more than 40% to get a grade.
Okay. And if we got less than 40%, then also we can continue, right?
Continue what?
Means for end exam, end term.
Yeah.
Means
Quiz 1, quiz 2, you get less than 40 also, don't worry. Finally, you have to get more than 40. But if you see, you eligibility to obtain final course, attending the interim is important. Then calculate final score is given, and to attend the interim eligibility is 40% of your first 7 weeks assignment.
Okay, but for means quiz 2 marks means what
Madam,
about
Anaina,
quiz 2?
madam, see,
Yeah.
regarding the minimum marks in quiz 1 or quiz 2 is not mentioned in the grading document, no. So why we should worry about that? Grading
Okay.
document shows
Yes.
only two things. One is eligibility is getting 40% in 7 weekly assignments, and attending one year. Actually, previously it was attending at least one quiz. Attendance in at least one
Okay,
quiz.
so if you are attending all the exam, then you should not be worried about it. Like it will be in the natural way, right? So you are attending both quiz 1 and quiz 2, no? So you
Yes.
should not be worried about it. Okay.
Okay.
Yeah.
Okay.
If in case you cannot attend, then this is something alternative way. Okay, because you
Oh.
are attending, so you need not be worried about it. Okay.
Okay.
Yeah. Okay. So maybe then we can start our revision session.
Yes,
So
madam.
yeah. Yeah. As we know, first let us revise the topics briefly. Then we will solve some problem. Then if you have some doubt, I will pick them. Okay. Okay. So we know about functions. What are functions, right? So what are functions? Functions is basically a particular relation, a type of relation from A to B, for which what? Any one of you can unmute yourself and let me know the definition of function.
For every element in A, you should have unique element in B.
Correct. So that means each
And every.
element
Unique.
of A should map to
Unique.
a unique element of B, right? So if it holds, that means a relation, if it satisfies this condition, then we can say this is a function, right? So we learned about so many examples of functions. So polynomials we know, right? So polynomials are also a particular type of function. Then we learned about quadratic polynomials, cubic polynomials, and we can go up to n degree polynomials, right? And also we can draw their graphs. Now we can do this function, we can see this function in another point of view, which is sequence, right? So sequences are nothing but a particular type of function. That means if I take the domain as natural number and the codomain as real number, this function will be nothing but sequence, right? So sequence is what? A collection of number. We know this A1, A2, A3 and so on. This is the sequence. This is how we can write a sequence, right? So this A1, we can look this A1 as an image of 1, right? Image of 1. Similarly, this A2 as image of 2. This A3 as image as 3. That means 1, 2, 3, these are for natural numbers, right? So if I just write the images under the map F in the sequence, that means 1, 2, 3, then this range set is basically nothing but sequence. So sequence is nothing but a particular type of function for which the domain is natural number, right? Any doubt?
No doubt.
Okay. Okay. So then we learned about limit of a sequence, right? Limit is what? Anyone of you? What is limit of a sequence? What do you mean by limit of a sequence? Yeah. Anyone of you just mute yourself and try to describe what a limit is for a sequence.
The maximum the sequence can tend to.
Yeah. So that means if we take n tending to infinity, then the sequential term will be tending to some number. That number is called the limit of the sequence, right? As n tending to infinity, that means a1, a2, dot, 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 an, sum up to a infinity, this term will be tending to some number L, and this number is called limit of the sequence. Now we also know that depending upon limit of a sequence, we can classify the sequence in two different classes, right? First is convergent, second is divergent, right? So sequence, when can I say a sequence as convergent sequence?
Limit tends to a particular one particular number.
Yeah. So if the limit is a particular finite number, right?
Finite.
If that means if the limit exists finitely, right? And when can we say a sequence divergent? When it is not convergent.
Not convergent.
Yeah. If the limit doesn't exist, or it is tending to infinity or minus infinity, right?
Or tending to two different.
Yeah, that means limit doesn't exist.
Can you repeat again? I couldn't hear. What did you say? Like limit doesn't exist or exist?
If limit doesn't exist, that means if I take n tending to infinity, then we can't say what is the limit, right? So for example, if I take our function is sine of n, okay, then do you know what is the limit when n is tending to infinity? What is the limit of this function? Can you say it? It can be anything from -1 to +1, right?
Yeah.
Then fn can be anything from -1 to +1, right? So this is an example where we can say
divergent, what you have written, if either limit
doesn't exist. DNE means does not exist, okay?
Okay.
Or it is infinity or minus infinity, okay? So this is a case where limit doesn't exist, okay? This is the case. Also, we can take this example, a well-known example, an equals -1 power n. In this case also, when n is tending to infinity, it can be 1, it can be -1 too, right? So we don't know what is the exact number it is tending towards, right? That means here also, we don't know what is the number. That means here also limit doesn't exist, right? Okay. So these are some example of sequences for which limit doesn't exist. Now, if I take this sequence, f of n equals to n, then as n is tending to infinity, f of n will be again tending to infinity, right? That means the limit is going towards infinity. This is also called a divergent. So this is also example of a divergent sequence. Okay. 4. If I take this equals 1 by n, then is it a divergent or convergent sequence?
Tends to 0.
Convergent.
So this is tends to 0. That means convergent, right? Okay. So this is how we can classify sequence as divergent sequence and convergent sequence, right? Now we have subsequences. So if you want to conclude a sequence as divergent or convergent, subsequences are also a key point which can help you with. So what are the subsequence? What is subsequence?
It is a sequence which we can get from the original sequence by taking
Subsets of the original sequence.
subset of the
Sequence.
It is a sequence and it is a subset of the
subset
original sequence.
original
Right?
sequence in that order.
Yeah. That means it will maintain the order and it is a subset, right? So if I have the sequence n, then 1, 3, 5, this is a subsequence, right? Also 2, 4, 6, this is also another subsequence, right? Agree?
Yes, ma'am.
Yes, ma'am.
But if I take this one, is it a subsequence?
No, ma'am.
Why?
Because your this 2, 2 is not there in any of the original sequence.
Correct. That means 2 we can't take twice. 5 also we can't take twice because 5 and 2 are at present one time in the original sequence, right? So this is not a subsequence, but these two are subsequences, right? Okay, wait. There are so many noises. Okay. So this is the subsequence. Okay. So one thing we have is if we have a sequence an, okay, and suppose bn, cn, these are subsequences of the sequence an, okay. Okay. Then if an is tending to L, it will imply bn, comma cn, both are tending to L. Okay. That means if I have the limit of the original sequence, then all the subsequences of that sequence will have the same limit. Okay. And even it is a vice versa. That means if I have a subsequence of some sequence and if I join them, that means if I take union of them, and if the union is equals to the sequence, the original sequence, that means and both the sequence, if they are tending to L, then we can imply that the original sequence will be also tending to L.
Madam, here one point you told, no, like AN union CN should be equal, I mean, BN union CN should be equal to AN, madam. It may not be a subset of AN also, no? Then also it will converge to L only, isn't it?
Yeah, if it is a subset of A, that means if you have AN is tending to L, then you can directly imply BN and CN, this will be tending towards L. Okay.
Yes.
Again, if we have BN and CN are tending towards L, that means the subsequences are tending towards a fixed limit, the same limit, unique limit. And if I just take the union of these two sets, these are sets, right? Ultimately. So if I take the union of these two sets and if we get this set,
No, here only, madam. It need not be union. No, it may be a subset of AN.
No.
It need not be equal. It should be equal.
No, yeah, it should be equal because we are implying the opposite direction, right? If this we have and this we have, then we can imply AN is tending towards L. It should be equal because if I take AN equals minus 1 power n, okay. So if I consider the even sequences A to N, suppose, and if this is 1, right? And the odd sequence, this is minus 1, right? So this sequence will tending towards 1 and this sequence will tending towards minus 1, right?
Yes, ma'am.
So in that case, we can't say anything because they are not tending towards the same limit, right?
Correct. No, my doubt was whether it should BN union CN, whether it should be equal to AN or it can be a subset of AN.
No, it should be equals to n. Like not, you can take n number of sequences. Here we can take it is as even sequence. That means all the even terms and this is as all the odd terms. Then if you just like take the union, then you will get all the terms, right?
No, I can even take first terms, BN, CN, DN also I can take, no, madam.
Yeah, then we can't imply it because okay, for example, suppose we have this sequence 1 1 2 1 1 2 repeating like that, right? Okay, suppose we have this sequence. So is this sequence convergent?
No, it is not, no, madam.
Yeah, not convergent, right? Now if I take the sequence of with this terms, like we will exclude 2 terms. So sequence is like 3n. So we will get 1 this a 3n minus 1. So we will get 1 this and a 3n minus 2. Okay, this will be 2 this. Okay. So these 2 sequences are tending towards the same limit 1, but their union is not equals to the main sequence, right? So we can't say here it is an example because their union of these 2 sequences is not the main sequence. We can't say that the limit of the sequence is 1 because we can see the limit doesn't exist.
Then we have to have one more caveat saying that BN tends to L, CN tends to L, and if AN has limit exists, like then only you can say BN plus CN should give AN. If
Yeah.
at all AN
So
should have.
it basically means what? I mean, if you take union and if it is equals to this, that means it basically means if a sequence has a limit L, then all the subsequences of the sequence will be having the limit L. And
Okay.
if all possible subsequence of a sequence has the limit L, then it will imply the sequence is also have the limit L.
Yes,
Okay.
ma'am. Now I got the answer. With that last example, it is proven that B, whatever subsequence is there, you take union, it should be equal to A, and then only
Yes.
the limit will tend to L
Yes,
for all the
correct.
3.
Because
Okay.
we can take any sequence, right? Even like all possible subsequence means you can take it in any order, right?
Yes,
You
yes.
can, yeah. That means so that is why I imply this line because if their union is the original sequence, then we don't have any disturbance here. Okay.
If it is not the original sequence, then we cannot say tell
Yeah,
what
then
is
we
AN.
cannot say. Yeah, then
We
we
cannot
cannot
say.
say. But
Okay.
if you consider all possible subsequences, then automatically their union will be the original sequence, right?
Yeah. Yes, whatever subsequence is possible.
Yeah, whatever. So you can take only the even term, only the odd term in union. Then it will be the original sequence, right? Also, you can take in this order, right? You can take 4n, 4n minus 1, 4n minus 2, 4n minus 3, this 4 sequences. So you can take any sequences, and if all of them has the same limit, then the original sequence also having the same limit. Okay.
Okay, got it.
Yeah. So for example, we can also say, suppose this, okay. Okay. So for this, this will be like minus, plus, like that, right? So we can write it as even and odd sequences, right? So if I take the even sequences, then we will get this sequence, right? And if I take the odd sequence, then we will get this sequence. So even sequence means the even terms, and odd sequence means the odd terms only, right?
Here both will tend to 0, no, ma'am?
Yes. Here both will tend to 0. And if I union these two set, then we will get the original sequence, right? So
Okay.
this an will be tending to 0. This is the limit of an. Okay. Clear?
Yes, ma'am. Yes, ma'am.
Okay. Now we can revise some of the formulas. Okay. So the first formula, if we have two sequences A, B, N tending to B, then their sum will be tending to this,
A plus B.
right? And if their subtraction will be tending to this, even their multiplication will be tending to this, right? And division also we can say like an by bn is tending to a by b, provided b is not equals to 0, right?
Yes.
This are known formulas. Then we have an important formula, sandwich. Sandwich formula, right? So what is sandwich formula? If we have three sequences, an, bn, cn, such that an less equals to cn less equals to bn, and if an and bn both are tending to some limit L, it will automatically imply cn will be tending to that limit L, right? It was the sandwich formula. Okay. So these were the main thing from sequence. Do you have any doubt related to the concepts? Any doubt? Okay. So we
Ma'am,
can.
I've got one.
Mhm.
That is, in like the sequence, if it's like in what to say? If the numerator is convergent and if the denominator is divergent, how do we like do that?
If the numerator is convergent.
Yes, ma'am.
Okay, it actually depends on the case. Like it can be anything. Divergent mean it can be go to infinity, limit doesn't exist. Both the cases are possible, right?
Yes, ma'am. Like, ma'am, in like the time mock quiz, there's a question in which like that is the case.
What was the question?
The question is, it's like an is equal to n minus 2, which is in the floor function, minus 4n
This
divided by, yes, ma'am,
minus 4n
divided by n plus 3 when n is odd, and then 4 minus 7n divided by 6 plus 2n when n is even.
Okay.
So, and they are telling us to find the limit of sequence a n.
Okay. So see, because it is a box floor function, that means it is always a finite thing, right? Now, if you have the same degree, like the degree of numerator and the degree in denominator, if they are same, that means the sequence will be convergent, first of all. Okay. That means if I take the odd case, we can take n as common and cancel it out. So we will get minus 4 from here. Okay. Right. right? Minus 4 will be the limit is.
Can you show once how?
Yes.
Can you show how?
Yeah, sure. We can take n as common. So we will get this by n minus 4 by 1 plus 3 over n, right? So if n is tending to infinity, this will be tending towards 0 and this will be tending towards 0, right? So this will be tending towards minus 4. Okay. Is it clear?
Yeah.
Yeah. Similarly, when n is even, then what will be the limit? Anyone? If n is even, what will be the limit? Minus 7 by 2, right? Similarly, we will take n as common. So we will get 4 over n minus 7 by 6 over n plus 2, right? So we can see there are two subsequences, even and odd, and their limits are different. So the n will not be a convergent sequence, right? Agree?
Yes, ma'am.
So this is how you can use the subsequences to solve this type of problem if you have some in even and odd form. Okay.
But ma'am, what is exactly the answer?
This sequence is not a convergent sequence.
No, like they're asking the limit. So
The limit for this sequence.
Does not
yes, ma'am,
exist.
they're asking.
Limit doesn't
Yeah, does
exist.
not exist, right? Yes, but like the next question is they are asking us to find like the sequence of Bn and they've given the formula for Bn. And we are supposed to like substitute An into Bn, right? But we can't do that here, right?
It depends. We have to see what is the exact DN sequence for that.
Can you please explain that to me? I'll tell you the question now.
Yeah, you can share the question. I will check it.
Yeah, sure.
Can you take a screenshot and share it in the chat box?
Yeah, sure, ma'am. 1 second.
Okay.
And can we comment here whether the function is continuous or not?
Okay, if limit doesn't exist, then the function will not be continuous, obviously, right?
Obviously, when n is natural, how can the function be continuous, ma'am?
No, it can be continuous in its own domain. So it depends on the domain also. You need not be bothered about it. So basically the thing is continuity when you are checking, we are checking on the domain. That means if at each point of the domain, if this is continuous, then it is continuous. So here we can't say like that because we have to check it at some particular point in that case. So let's not be bothered about continuity for sequences because right now we don't have this type of thing in our syllabus. Okay. We don't need to check continuity in a natural number. We don't have these things in our syllabus.
But ma'am, there are some questions that the function is continuous or discontinuous.
Yeah, in that case, the domain is not natural number for sure. In that case, they will give the domain as real number. Okay.
So for that, we have to find the limit first.
Yeah, if limit exists and limit is equals to the functional value at that point, then the function will be continuous at that point. Otherwise, not. So we have to check by the definition. Okay.
So can you take one example for that?
Continuity.
Continuous.
Yeah. After that, after completing the sequence thing, I will go to continuity. Then we will take some examples.
Okay, ma'am.
Okay.
Ma'am,
So
I've given it in the chat box.
Okay, sorry. So we had the floor function of n. This is not necessarily a finite. We have to consider it. So if n is an odd number, then what is the floor function of n? Sorry, I just considered it the curly bracket. It was not the curly bracket, right? It was a floor function. So this is not finite. So if n is odd, that means n can be written as some 2m plus 1 in this form, right? If I take
Yes, ma'am.
then we will get m plus some half, right? And if I take box, then what will be the value of this box function?
M.
So this is what? This is m, right? Right? So what is the
Where
m?
did we get the n by 2 from, ma'am?
What?
Where did we get the n by 2 from?
It was n by n divided by 2, not subtraction. In this
Yeah.
it was
Got
n
it.
by 2. Okay. So if n is odd, then we can express n as some m 2m plus 1 by 2, and then box of n by 2 will be m, right? And what is m?
Yes, ma'am.
N is equals to 2m plus 1. So m will be equals to what? N minus 1 by 2, right? Right? Is it clear?
Yeah, till here it's clear.
Okay. So when n is odd, we have the function as n by 2, box of n by 2 minus 4n by n plus 3. This was the function, right?
Yeah.
It is the function. So now we know the box of n is m and m is n minus 2, n minus 1 over 2, right? Minus 4n by n plus 3. Now we can do it, right? So this will be n minus 1 minus 8n by 2n plus 6, right? So this will be minus 1 minus 7n by 2n plus 6. So what will be the limit then?
Minus 7 by 2.
Correct.
0.5.
When n is odd. And when n is even, directly from the definition, the limit is minus 7 by 2, right?
Yes.
So again, the limit is minus 7 by 2 when n is odd. Sorry, even.
Ma'am,
That
can you
means
Cases, value is the same.
what?
In both cases, value is the 7 minus 7
Yeah,
by 2.
yes. In both cases, the value is same, minus 7 by 2. That means the limit of an is minus 7 by 2, right? So now we can directly use the limit of a to solve bn, right?
Ma'am?
Yeah.
Ma'am, can you again explain why n by 2 can be written as n plus n minus 1 divided by 2?
So if n is odd, n is an odd natural number, right? Then n can be written as some 2m plus 1, right?
Yes, ma'am.
Okay, where m is some natural number again, right? So
Yes,
then we have greatest integer function of n by 2, and this will be greatest integer function of 2m plus 1 by 2, which is equals to m plus half. And if I take the box function of m plus half, it will be m, right?
No, I didn't understand why it will be n.
Okay, this is m. this is an integer and m plus 1 is another integer and m plus half is somewhere here. So if you take the box function of a point somewhere here, it will be the integer which is just before
Yeah, got
that
it.
point, right?
Got it. Yes, ma'am.
Yeah. Now we have n equals to 2m plus 1. So we can express m in term of n, which will be n minus 1 by 2, right? Right? From this
Ma'am,
equation, we can evaluate the value of m in terms of n.
ma'am, just a minute, ma'am. Ma'am, when we write m plus 1 by 2 as m, then how we reach the conclusion that it can be written as n minus 1 divided by 2?
What?
Ma'am, like I understand the part like how can we write it as m, but how did you say that we'll write it as n minus 1 divided by 2?
Let's simplify in term of
Yeah,
nothing else.
from this equation, we are simplifying it, no?
Okay.
N equals to 2m plus 1.
Got it.
Okay.
Madam,
Yeah.
what I did is, we know n is odd,
Yeah.
and n by 2, if you take, for example, my odd number is 5, 5 by 2 is 2.5, so we have to take 2.
Yeah.
So what I did is n by 2 minus 1, that floor function we can take, no? N
Yeah,
minus,
what you did is, I understood your process. It is also correct, but again, we are doing the same thing. You're doing it with some intuition, and I'm doing it in some process. That's the
mathematical
difference.
process.
Yeah, basically, see,
Yeah,
if
basically
n is odd, so if you take the odd, half of the odd of anything, and if you take the floor, so anyway, it will, have the even number.
Yeah.
Or whole number, something like that.
Okay, so the thing is, you can do it in intuition too, but it is better to do it in process, right? So that
Yes.
the visualization will be more easier then, right? Okay, so is it clear now?
Yeah, first part is clear, but second part.
Second part, what about second part? So
Yeah,
the
that
limit
is,
of this sequence is minus 7 by 2. It is clear, right? We can take n as common, then cancel them out. So we will get minus 7 by 2.
right.
And similarly for the even term also, we will do the same thing and we will get the limit as minus 7 by 2. So, and
they
we
are
know that,
continuous, right?
yes,
Then it is continuous.
we will not talk about continuity for a sequence. Okay. We don't have this type of thing in our syllabus. Here the domain is natural number. So we will not talk about continuity. It will be automatically continuous in a discrete domain. But you don't know what is a discrete domain and all this thing. So we will not go to this type of thing right now. We will only check the limit of the sequence. Okay. That means we have simple things. We have two subsequences of the sequence. If I take the event terms, then we have the event sequence. Event sequence is tending towards minus 7 by 2. And if you take the odd terms, then we will get the odd sequence, and odd sequence is also tending towards minus 7 by 2. Right? So both even and odd sequences are tending towards minus 7 by 2. Then it will automatically imply the main sequence will be tending towards minus 7 by 2 because their union is the main sequence, right? What I just told you.
Yeah. Can you scroll down a little bit?
Yeah. This one?
No, the second part.
This
the
part?
Function that it has been calculated. Little up. Yeah, here. It's okay. Thank you.
Yeah. Is it fine now? Can you move towards another problem?
Yes, ma'am.
Yes.
Okay. Okay, so we can have another example. Suppose you have some e power n plus 2 minus okay. So what will be the limit of this sequence? What will be the limit of this sequence?
Zero. Sorry, 1.
Okay, let us see. So we can take e power n as common. Then what we will get? E square minus 2n cube by e power n by 1 plus 10 n cube e power n, right? Now, what is the limit of this thing?
0.
Correct, 0. And what is the limit of this thing?
Same 0.
Yeah. You can use L'Hospital rule to compute the limit. Okay. So what will be the limit of this? E square, right?
Yes, ma'am.
Yes.
Okay. Any doubt?
Ma'am, can you explain question number 12 to mock quiz?
Excuse me, ma'am.
Yeah.
Ma'am, why didn't we take n cube common instead of e?
Because we have to take the higher term. And exponential function, we know that we compared the growth of exponential function and polynomial function, right? We know that the exponential function is the most rapidly growing function, right? That means the growth when n is tending to infinity, the growth of exponential function is the highest. Compare it to any polynomial function, right? So we will take the function for which the growth is like. Are you getting my point? So if I compare the exponential function, the growth of exponential function is more, but the growth of polynomial function will be like that. Okay. So basically, exponential function grows more rapidly rather than any polynomial function of any degree. Okay. So we took e power n as common so that we can avoid infinity by infinity term, right?
Yes, ma'am.
Yeah. So if we take exponential function, then we can avoid the infinity in our numerator. Okay. And if you divide it with it, so 1 over infinity is something which we know it is tending towards 0, or 1 over minus infinity is also tending towards 0, right? So we can take 1 over infinity in our limit, but we can't take infinity in our limit, right? That is why we can take e power n as common. We should take e power n as common. Okay.
Okay, ma'am.
Yeah.
Can you please solve it with the other method?
Which other method?
L'Hospital rule.
Okay, so the thing is, you can use the L'Hospital rule, but for that also you have to simplify it. I mean, here you have the exponential function, right? So you have to simplify it, then you can use the L'Hospital rule. Like otherwise, there will be exponential function constant. Like there will be a exponential function. If you use the L'Hospital rule, after some stage of derivative, we will get n plus 2 by e power n. This will be there. Then we have to cancel e power n out so that we can get e square. Okay.
Excuse me.
Yeah.
Ma'am, can you please explain how can we apply L'Hospital rule on question number 12 of mock quiz 2?
Okay, so mock paper I don't have with me. You can take a screenshot and maybe share it in the chat box. Then I will take it.
Okay.
Yeah. Okay. So is this clear?
Ma'am, can you please explain how 2n cube divided by en is equal to 0?
Okay, this is, we can use the L'Hospital rule. So this is in infinity by infinity form, right? So if we use the L'Hospital rule, we will get 6n square in the next step by e power n. Then again 12n by e power n. Then 12 by e power n, right? So is n is tending to infinity, that means this will be tending towards 12 by infinity, that means 0.
Yes, ma'am. Got it. Thank you.
Ma'am, I shared the image in the chat, ma'am. Can you please take it out, ma'am?
This one.
Yes, ma'am.
Okay. So here you have x power 4. Okay. First of all, we can simplify it, right? So we can write it as 9 plus 8 x squared plus 5 e power minus 3 x power 4 by x power 4, right?
Yes.
Then if I take limit here and limit here, so from here we will get 9, and for here we have to use the L'Hopital rule, right? So let us check. 5 also we can take outside. So we basically have limit x tending to a 0 e power minus 3 by x power 4 by x power 4, right?
Yes, ma'am.
Now we can write it as limit x tending to a 0 1 over x power 4 by e power 3 by x power 4, right?
Ma'am, can you explain this step?
Okay, e power minus something means what? 1 by e power
One
that
upon
something.
yes, ma'am.
And here we have 1 by x power 4. That is what we are taking.
Okay, so 1 upon e raised to power 3 upon x power 4, right?
Okay, right?
Yes.
Is it fine now? So this will be in infinity by infinity form, right?
Yes,
So
ma'am.
once you can then do the derivative of 1 by x power 4, and again here you have to do the derivative of 1 by x power 4, right? So this will be cancelled out, then we will get a 3 extra. So now can you do it?
Yes, ma'am.
Can you please show it, like show?
What?
Can you show the steps?
Yeah. So if I do use the L'Hopital rule, this is basically in infinity by infinity form, right? So if I do the L'Hopital rule, we have to derivative x power 4. I'm writing it as 1 by x power 4 dash. And if I have this, so for this also 1 by x power 4 dash e power 3 by x power 4. This will be the derivative, right? Right? I'm not writing down the derivative explicitly. Rather, I am denoting it with 1 by x power 4 whole dash. Okay.
Okay.
Then we can cancel this two term outs. So we will get limit x tending to 0, 1 by 3 e power, right? So this will be when x is tending to 0, that means this will be tending towards infinity, and 1 over infinity means this will be tending towards 0. So the answer will be 9.
Yes.
Okay. Clear?
Yes.
Yes, ma'am.
Okay.
I was confused to, use the L'Hopital rule in the third term, but by how some intuition I arrived to the 9, but yeah, now I'm more clear.
Now is it fine?
Yeah.
Ma'am, if I don't separate the terms and directly hit the L'Hopital rule, don't you
Can
think
do
it
it.
will be more easy then?
How? I guess it will be more complicated.
Okay.
Yeah,
Ma'am,
it will
like,
be more complicated.
It will be more complicated.
Because, first time I tried like that,
Mm-hmm.
and then I ended up, by solving the, this, removing the, the way you did 9x, 9 plus 8x square plus 5. The only problem that, I was dealing with, that I could not use the, I could not click in the mind that, in the third term, I can use the L'Hopital rule. But somehow I arrived at, in the, denominator, it will be infinite. So anything divided by infinite, it will be 0. So I come to the conclusion to the 9 by intuition, not by the, process.
Ma'am, mock test
And
seems
even if
very
we don't
complicated
use
now.
the L'Hopital rule and just cross out the x power 4s, then also we'll get the answer as 9, right?
What?
Ma'am, if we don't use L'Hopital rule here,
Okay.
just cross out x power 4.
Then
right?
how will you get 9?
Simply, ma'am, like 9x to the power 4 upon x to the power 4, then the x will cancel out, and like this, when we go on,
And
we'll.
what about this term? How can you derive this term?
See, we have to be very sure that, in last two term, any one term should not be, infinite. If any term is infinite,
Yeah.
then addition will be ended to the, diverge to the infinite
Yeah.
side.
So here it is in 0 by 0 form, right? Which is a undefined form. If
Right.
you have some indeterminate form, then you have to use the L'Hopital rule. Otherwise, we don't have another option right now. Okay.
If we, ma'am, use 5e raised to power minus 3 by 0, then it will reach to minus infinity. So
E power minus infinity. E power minus infinity.
yes, e raised to power minus infinity
That
is
means 0.
Yes, and then we'll
X power 4 is also 0. So it is 0 by 0 form, right?
okay.
Okay. So 0 by 0 form once we have, then we can derive something like using the division rule. Then we have to use the L'Hopital rule.
Yeah, got it. Also, ma'am, I've shared one question in the chat. Could you please check it?
Yeah, sure. So let me just clear. Is like all of you are okay with it, or if you have any doubt, you just ask. Then I will delete this picture.
Yeah, you can share this picture. I hope that will be very okay.
Now I also have shared one more question for you. The mock test is bit complex, ma'am. Is it normal or like?
Okay, so you should be comfortable with some of the questions.
Yeah, ma'am, some of the questions are okay, ma'am, but like few questions are like confusing. I won't say that they're complicated, but they're confusing.
Yeah, that can be the case. The thing is, you have to think about it in some different angle so that you can solve it. Okay. But complicated means over complicated thing will not be in the exam.
Okay, ma'am.
Yeah, in the exam you can express something in moderate level. Okay. So in this, what is the doubt in this problem? We have to calculate the roots only. You have to equate the problems and we have to calculate the roots using the logarithmic formulas.
Ma'am, can you just explain me the logic here? I'll solve it if that's.
So if you have f and g, you have to equate them and you have to so we have log 2x plus 3, 6x square plus 23x plus 21. And here what is g? G is minus log 3x plus 7.
Actually, ma'am, this is the mock question and it went too lengthy, so I thought there might be a easy solution for this.
No, if you have like this, that means basically you have to equate them and you have to use the logarithmic formulas and finally you have to arrive to a root.
Okay.
This is the process. Like,
so this is a lengthy process only. There is no shortcut for this.
I don't think so. Like you have to find the point of intersections, right?
Yeah, we have to equate both the equations.
Yeah. So doing the calculation, you can factorize them. Then you can maybe find some shortcut. Like maybe if you have this 6x square plus 23x plus 21, maybe this quadratic function may have the factor 2x plus 3.
Actually, ma'am, it is only solvable by discriminant formula. They have I couldn't find any roots for the quadratic equation.
Yes, let me check it. Okay, 6, if I take 3 as common, 9. And then we have
Can you hear me?
yeah, yes.
Actually for the question number 5, it is a MCQ. There is only one choice is correct.
Yeah.
Correct, madam. And it says in the 4th line, she found the harmful cosmic ray passes the intersection point. So value of waste and prevent. So third will be the answer. No, it must pass through the intersection. Then only Earth can be saved.
Yeah, but we have to also find the value of A, right?
Yeah, no, for this 5th question, directly third option is the correct option, no?
Yeah.
Okay, yeah. Yes. And also, and that is what I said is, if you just take this quadratic thing, like 6x, for example, 6x square plus 23x plus 21, and try to see whether there is a factor 2x plus 3 of this thing.
Okay, ma'am.
Okay, and try to evaluate this in this form. So I guess this will be the case. Okay, so see, here we have this, right? We can maybe break it 6x square plus some 3x. Okay, not 3x,
5x, ma'am.
9x, then 14x maybe, right? Right? Then take 3 as common, so we will get 2x square plus, sorry, 3x as common, 2x plus 3. Then again take 7 as common, so we will get 2x plus 3. So this factor will give 3x plus 7 into 2x plus 3, right?
Okay.
Now if you use the multiplication rule, 1 will be 1, you can find this factor with this base will be 1, and this factor with this base, you can relate it with this.
Yeah, now it seems easy.
Okay, so you have to follow this type of thing. Okay, try to factorize this equation. I guess this will become easy.
Yeah. Okay. Thank you so much, ma'am.
Yeah.
Ma'am?
Yeah.
Ma'am, if we have a function and we are asked if there is a unique linear approximation at a particular point, or there are two possible linear approximation, how can we answer that?
If the function is differentiable, linear approximation is what? Nothing but the tangent line, right? So
Yes,
if
ma'am.
we know that if the function is differentiable, then we have a unique tangent line, and if we have a unique tangent line, then the function is differentiable, right? So if the function is differentiable at some point, then you will find a unique linear approximation.
Okay, ma'am. Ma'am, I have shared one question in the chat. Can you explain the third option? Oh, sorry, first option, first and second.
This one?
Yes, ma'am.
First option. If is
First and
continuous,
second
but
option, ma'am.
if m equals to 5, m equals to -8, then if it's continuous and differentiable everywhere. So you can directly put the value here and check the continuity.
Ma'am, like, okay, let's start from the first point. Ma'am, when I was checking if the function is continuous or not, so I was like,
So
first one was not.
what is limit extending to 0 minus
Okay,
this
so
5 e power x minus 8x, right?
like, yes, ma'am.
So we will
Ma'am,
get 5.
5, yes, ma'am.
And this is equals to f of 0, which is equals to n, which is equals to 5. So this will be continuous, right?
Yes, ma'am.
And this is equals to the limit extending to 0 plus fx. Similarly, you have to check the differentiability using the formula.
Ma'am, if we are checking differentiability here, how
At
will we
0.
solve the m here?
What?
Can you for one solve the differentiability at f is equal to -3? The third point.
Okay. So you have to check the differentiability at 0. So we will get this h tending to 0, f 0 plus f of h minus f of 0 by h. Okay. So limit h tending to 0 plus means this. Okay. So 4 h square minus 3h plus 5 minus 5 by h. So this will be cancelled out. Then this will be, this term will be 4h minus 3.
4h minus 3.
This will be minus 3, right? Similarly, we can check the right hand, left hand limit. What will be the left hand limit? This formula we have to use.
F of 0 minus f of h divided by h. Okay, ma'am, got it.
Got it?
Yes,
So we will have 5 e power h plus mh minus 5 by h. Then again it is in 0 by 0 form, so we have to use the L'Hopital rule.
Ma'am, we are computing in 0 minus here, right? So we will use f0 minus fh, right?
Yes.
Okay, ma'am.
That is why you use this function, right?
No, ma'am, I'm asking like when you are calculating the left hand limit, for checking for the differentiability of left hand differentiability. So the formula is different, right? We have to take minus outside.
Okay, we have two different formulas. You can take the minus here, you can take the minus here also. Last in the summary, in the doubt clearing session of week 8, I already told these things. Okay, so for differentiability, you can use this thing like you can that if h plus a minus f of a by h, you can take this as fixed, and for left you can take h tending to 0 plus minus, and for right you can take h tending to 0 minus. If you are not taking 0 plus and 0 minus, then you can change the sign in f of a plus h minus f of a there.
Ma'am, can you write the formula for left hand derivative and right hand derivative?
Okay, so basically you can write this f of h plus a minus f of a by h limit is tending to 0. It is equals to limit is tending to 0 plus f of h plus a minus f of a by h. Okay, these two things are same. And if you taking the right limit is tending to 0, what you know, the formula is known by you is by a. This, right?
Ma'am, this is for left hand limit,
this
right?
Is for left hand limit, right? So
yes,
this is also, we can write it as 0 minus f of by h. This is also, we can write it in this form, because when you are taking h tending to 0 minus, that means h is already a negative number. So if h is a negative number, that means here we are also getting the negative, here we are also getting the negative. So these two basically are alternative definitions. You can use any one of them. Okay.
Okay. Got it. Thank you, ma'am.
Madam, in the previous slide, you wrote f of 0 equal to 5. Where it is mentioned?
F of 0 is equal to 5, it's in the question. So if x is greater or equals to 0, then you have to take the second function. That means you will get n, and n is equals to 5 given in the second option, right?
Okay.
That is why f of
even right hand limit, left hand limit, mx. For that also you wrote 5, ma'am.
Yeah, we are so we are getting 5, right? So if I put the limit here, what will be the limit? 5, right? This will be 0, and this will be 5 into 1, so 5.
Yes, so it will be 5.
Okay.
Right?
Okay.
Yeah. So individually, if you find the left hand limit and right hand limit, both will be 5, and the functional value at 0 is also 5. That means we can imply that the function is continuous, right?
Okay.
Anything else? This one is clear, right?
Yeah.
Yes. Ma'am, is there any specific formula to calculate a linear approximation?
Yeah, it's given.
Yes, you have a specific formula. So the formula for tangent. So the thing is, once we suppose this is a curve, okay, and this is the tangent with the slope, this is theta, and we know that the slope of this tangent line is f dash a, right?
Yes.
And linear approximation is nothing but the tangent line, right?
Yeah.
So if you have the line and you know 2 points. So this is one point, a, suppose a comma f of a. This is a point over the line and this is the slope of the line. Okay, then we can determine the equation of the line, right, using 1 point and slope, right?
Y minus f of a.
Y minus f
F
of
of
a
a.
equals to slope
Yes, f
into
dash
x
a
minus
into
a.
x minus a.
So y will be equals to f of a plus f dash a into x minus a. And this is the equation of the tangent line, and this is the basically equation of the linear approximation at the point a comma f of a.
Okay, ma'am. Thank you.
Okay, maybe we can solve one more problem. Suppose you have the function okay.
Ma'am,
Yeah.
can you please take an example for linear this thing, linear approximation?
Sure. Okay, so we can maybe take f of x equals to some x square plus 2x plus 1. Suppose this is a function, and let add a equals 4. Okay, so this is the example. Just try to solve it. The function is given and you have to calculate the linear approximation for this given function.
Ma'am, I have a doubt.
Yes.
In one of the non-graded assignments, a simple question it is, a sequence can be defined from, it's any sequence is a function defined from natural numbers to real numbers. Real numbers, I mean, even it can be defined from natural numbers to integers.
Real number, you once you are taking the real number as codomain, that means you are also or like considering all the subset of real number. That is, integer is also a real number, right?
Yeah.
So we are taking the broader set, the bigger set. So
the only constraint is domain should be natural numbers.
Yeah, yes. Domain should be natural number and the codomain is real number. Range can be anything, but the codomain is real number.
10x minus 15.
Yes.
Yes, ma'am.
Okay. So first we have to calculate f dash x. What is f dash x? 2x plus 2, right? Then what is f dash 4? 10. Now you can apply the formula. So y will be equals to f of a plus what is going on? When you're doing something, please don't forget to mute yourself. Okay. So 4, then x minus 4, right? Now what is f of 4?
25.
25, right?
Okay.
Plus what is f dash of 4? This is 10, then x minus 4. So this is 25 plus 10x minus.
So 10x minus 15 is
Right? So this is how you can calculate the linear approximation for any function. Okay, fine.
Yes, ma'am.
Okay. So if we take this example, suppose you have f of x equals to x square minus mod x when x is less than 0 and x square plus mod x when x is greater or equals to 0. Whether this function is differentiable or not. You have to determine whether the function is differentiable or not. We can break the function.
I think it's not differentiable.
Okay, so you are directly concluding it after seeing the mod x, right?
No, I've calculated it using the formula.
Okay, so this is a googly type of question. If x is if x is less than 0, then what is mod x? Is minus x, right?
Yes.
And if x is greater or equals to 0, what is mod x? Is plus x?
Yes.
What is this function? This is the polynomial function, right?
Yes.
So now polynomial function is everywhere differentiable, everywhere continuous, right? Nice functions.
Oh.
But see, x square minus
Yeah.
inside mod only you are having minus x, no?
No, when we are mod of x gives the value minus x when x is less than 0. That means minus of minus x, right?
The minus of
But
mod
is
x.
it differentiable at 0?
Yeah. It's a polynomial function.
Yeah, I understand. But in this case, in this particular case, is it differentiable at point 0?
Yes.
Oh.
So mod x is not differentiable at 0, but this function is a polynomial function. It was just a googly type of question.
When I have to evaluate the functional value at minus 3, what
Yes.
I will do, ma'am?
So
I'll put minus 3 whole square minus mod minus 3, no?
Yes.
So mod minus 3 is 3.
So no. See, what is the mod function? Mod of x equals to minus x when x is less than 0 and x when x is greater or equals to 0, right?
Okay, it's not like when...
that means if minus x minus 3, the mod of minus 3 is also 3, right?
Yes, madam.
That's the thing. Like, that means the x is negative. 3
No, I couldn't get this.
is the modulus value. What is... Okay, x is actually minus 3 here, right?
Yes, madam.
And
I am
the
putting in
modulus is
between two.
3.
Yeah.
Modulus is 3. But we want the value of x here. What is x? X is minus 3, na?
Yes.
That is what we are doing, the same thing. We want the value of x here. So when x is less than 0, modulus of x is minus x. This is what? This is minus x, right?
Which one, ma'am?
This is minus x, na? Modulus of x is minus x, right? When x is equals to minus 3.
But when we'll put it into the equation, it will come out as 3 only, na? That is what I...
Yeah,
So,
minus plus, so it will be x
yeah.
plus.
No, sir. We are jumping. See,
See, if you take, the thing is, if you take any negative number, for example, we are taking x equals to minus 3. This is a negative number, right?
Yes, ma'am.
And mod x equals to minus x. right? What is mod of minus 3? 3.
Okay.
This is minus of minus 3. That means this is minus x, right?
Okay.
Got it?
One step. Okay. 3 can be written as minus of minus 3, where
Yes.
minus 3 is x.
Yeah.
So that's why you're writing minus x.
Yeah. So when we are taking any negative number, that means modulus of that number is minus of that number. Because modulus means what? We are neglecting the negative sign, right? So you are taking a negative number and you are taking a extra minus over the number. That means minus will be cancelled out and we will get a positive number. That is what mod do, right?
Okay, correct, madam.
Yeah, so this was the googly type of question. Here, after seeing the mod, you will directly conclude, no, this function is not differentiable, but this is not the case. This is actually a polynomial function and it will be differentiable everywhere.
No, I was thinking that, this is differentiable everywhere, but except 0. That is what, it was
Yeah,
coming
that
into
is
my
what,
mind.
because mod x is there, you will definitely think it is not differentiable at 0, but the function will be differentiable at 0.
Yes, because when we arrive at the individual function
Yes.
at particular point, then yeah, it's differentiable.
Yeah. So you can also check it via the definition, but if you
Yeah,
just
RLD, we can
use
check
the
it, but,
definition of mod function, we will directly get it is a polynomial function and it is a nice function. That means
Right.
differentiable everywhere.
Right.
Okay.
Ma'am, I have a similar doubt, but in that question, it is asking the points where the function is continuous.
The points?
Where the function is continuous. I have shared 2 screenshots. You can check them.
Whatever you thought of doing today, you have completed, ma'am?
Yeah, the main thing was I wanted to discuss some problem and discuss the topics. So that is what the thing. So I did 2-3 problem. It was enough, and we are picking the doubts from yours. So it is the doubts are also good. So it is enough to solve them.
Topics you have completed, ma'am?
Topics, no, I guess I haven't yet completed the limit and thing, but we started discussing the problem over limit, continuity and differentiability. So okay, maybe okay, let me first just quickly revise the things in week 8 and then I will go to those 2 problems. Okay.
Okay.
Yeah. So as you already know the things, so we are just quickly revising it. So the first thing was limit. The limit of a function is a general case of limit of a sequence, right? So at any point we can calculate the limit of a function, and we know that we had left hand limit and right hand limit, right? So left hand limit means the sequence will be tending towards the point from the left hand side, and we will use the negative sign there. So at A, suppose we want to find the limit at A, the left hand limit is denoted by limit extending to A, f of x. That means we are going towards A, but from the left hand side of A, and we are checking the functional value. And right hand limit is nothing but limit extending to A plus f of x, right? These are the left hand limit and right hand limit. And what we know that if right hand limit, right limit and left limit are equal, then we can only say that limit exists, right? At A, right? Now, if limit exists, then we can write it as limit extending to A, f of x. And this is equals to some number L. L is a finite number, right? In that case, we can say limit exists, right? L is a finite number. If in particular L is equals to the functional value of that point, then what we say? Then what we say? What? F is continuous at that point, right? This implies at A, right? These definitions are well known, right?
Yes.
Yeah. So, and one quick remark is, if a function is continuous, it automatically it will imply that limit exists. So for a function, if limit does not exist, then the function will not be continuous automatically, right? So continuity implies limit. Okay. Then we learned about differentiability. So differentiability is what? If I have the function f and at the point A, suppose we want to check the differentiability, we denote it with f dash a and we write it as limit a is tending to 0, f of a plus h minus f of a by h, right? This is the definition for differentiability. Okay. And if a function is differentiable, if and only if at A there exists a unique tangent, right? Right. So if the tangent exists, then the slope of the tangent, is equals to m. This is equals to f dash a, right? Then the equation of the tangent is what we just write, right? So it is f of a plus f dash a. So this is the linear approximation at a of the function f, right? And again, one more remark, if the function is differentiable, then we will get the continuity, right?
Yeah, so vice versa.
Yeah, differentiable, not vice versa. A continuous function may not be differentiable, but a differentiable function is always continuous.
Okay. So differentiability gives the confirmation that it's continuous.
Is continuous, and continuity implies limit. So if differentiability is most strongest property, then continuity, then limit. Okay. So example we can take mod x. This is continuous but not differentiable. Right?
Not differentiable even at 0?
At 0. Not differentiable at 0 only.
This is not.
Okay. Any doubt? Any doubt related to these concepts?
No.
Excuse me, ma'am.
Yes.
If we ask the points of discontinuity, then we have to check only those points in the piecewise function which are visible, like x greater than 2, 0.
Which can you repeat again? What was your doubt?
If we have to find the points of discontinuity in a piecewise function, we have to find only the points which are visible in the discontinuity range.
Yeah.
Is that
so you want to find the points of discontinuity, right?
yes, ma'am?
Yeah. So visible means, what did you mean by visible?
Suppose f of x is equal to 0 when x is greater than 2 and and 1 when x is less than 2. So we have to find only at 2.
Yes. That means the boundary points, at the boundary points of the domain. Like at the point we are breaking the function. So for example, maybe here we broke the function at 0. That is why we only check it at 0. Otherwise, the function is a polynomial function, right? Except at 0. So when we are like defining a function different interval, you have to only check it on the boundary points. Okay.
Okay, thank you.
So yeah, do you have any other doubt?
Ma'am, in one of in the mock 2 question, the very first question.
Okay. Maybe you just share the screenshot with me.
Shall I share that?
Yeah. So I was solving this question. Find the total number of points in this at which F is
Ma'am, this is a
not
sub question. The main question is previous image.
this.
Yes,
This
ma'am.
is F, right?
Yes, ma'am.
Okay. So this is a box function, and that means the greatest integer function. And what we know, the greatest integer functions are not differentiable. Limit doesn't exist even at the integers point, right? That means at -3. Okay, so -3 is the boundary point. So at -3, the limit will exist, but -2, -1, the limit will not exist. Then 0, you have to check using the definition. And then 1, 2, and 3, you have to check using the definition.
Ma'am, can you solve 1, 2, or 3 example?
Okay.
Like
So
-2 and 1.
what about 0? So it is not differentiable at -2 and -1. It is clear, right? So what about 0? If I tend towards 0 from the left hand side, what we will get?
On left hand
0.
side, 0.
0. So at 0, it is 0. And if I tend towards the right hand side of 0, what we will get? 1 point something means
1.
the curly bracket thing I'm saying.
Okay, point 1, point 1.
No, we don't know. Like we are tending towards 0, right?
Okay, there is a 0, 0.
Then it will be 0 point some 0, 0, 0, 0, some 0 up to 0. Like we don't know
Yes.
what is it. Is an infinite time thing, right?
Yes.
So at 0, it will be, we will find 0 from the right hand side also, right?
Yes.
Okay. So at 0, this will be continuous. So 0 we will not see. And what about the point 1? So if I tend 1 from the right hand side of 1, then what we will get? That means
0.
it will be 1 point some 0, 0, 0, 0. It will be like that, right?
Yes.
And if I tend 1 from the left hand side of 1, then it will be 0 point some 9999 up to infinity, right?
Again 0.
No, not 0. So if I tend from right hand side, curly bracket means what? We will consider the points
Okay.
after the decimal thing, right?
Okay, ma'am.
So this will be the left hand side limit, and this will be the right hand side limit.
Okay, so 2 and 3 will also be discontinuous at these points.
Yes. At 1 and 2 it is discontinuous, but at 3 is again the boundary point, right? So at 3, what is the case? At 3 also it will be discontinuous, but
Yes.
why? At 3, the left hand side limit we will get 2 point some 9999. That means that 9999 we will take, 0.9999 we will take. But what is the curly bracket 3? This is 0, right?
Yes.
Okay. So 0 point some 9999 means it is something close to 1 and it is 0. So that means the left hand limit is not equals to the functional value at that point, right?
Okay, ma'am.
That means this is again a discontinuous point, right? So
Yes.
3. So total number of discontinuity will be 5.
5.
-1, 1, 2, 3. Is it fine?
Okay, ma'am.
So it is clear to all of you, right? Okay, so it was so accepted answer is 5. Okay. Anything else? Any other doubt?
Ma'am, I have pasted the question in the message box.
This one? First one?
This one.
This one?
Yes, yes.
Okay, so domain of the function is this. Which of the following statements are correct? So what is the domain of the first function?
I mean, I have a doubt that whether they should be open brackets or closed brackets, because if we consider them to be open brackets, then
no, we don't have any problem with closed bracket, right? If I put any of the point, we will get 0. So root over 0 is defined, right?
root over -0 doesn't exist, no, ma'am. That sort of
-0 is what?
Nothing.
-0 is 0 again, right?
Suppose we take 3.
So we will get root over 0.
0, that's it. So the first option can be considered. It can be right.
Yeah.
Okay.
Like if you are finding the domain as open interval, and if you have only doubt with 2, 3, 4 and 5, then the function is defined at 2, 3, 4 and 5, right? This will be root over 0. That means we can define the function at 2, 3, 4 and 5. That means we can include them in our domain.
Okay.
Okay.
Ma'am, the third one, actually, suppose generally any function is given and it is not defined in a domain range or anything. Suppose the third function f of x is equal to x cube plus 5. So differentiation of derivative of that will be 3x square.
Yes.
So x can take any value in the real numbers.
Yeah.
So it is differentiable everywhere.
It's a polynomial function, and polynomial functions are from real line to real line, and polynomial function of any degree, they are basically nice function. Nice functions means they are differentiable. Even they are differentiable infinite time. That means the first derivative, the second derivative, the infinite number of derivative even exist for a polynomial function. Okay. So the polynomial function is differentiable everywhere.
Okay.
Okay. Yeah. Anything else?
Ma'am, I have shared the another doubt.
This one?
Yes. So I'm getting problem in the checking differentiability.
Checking differentiability of the function p or q?
Yes, ma'am.
Which one?
Can you check both, please?
Okay.
From my assessment, it is that they both are continuous.
Okay. So I'm not checking the continuity then. Maybe we need to check the differentiability. Okay. So what will be the right hand limit? Okay, we will check the differentiability at 8. So 8 tending to 0 minus f of h plus 8 minus f of 8 by h. Okay.
Okay.
So we can directly put them in this equation. So what we will get? This term will be f of 4 e power h minus 4 by h minus 4 by h, right? Right? Here you just have to put h plus 8 instead of t, nothing more than that. So now if I just calculate it, so what we will get? 4 e power h minus 4h by h square. So this is in 0 by 0 form. So we can use the L'Hopital rule. So we will get 4 e power h minus 4 by 2h. Then again L'Hopital rule. So we will get 4 e power h by 2. That means basically 2 e power h. Now if you put 0, so we will get the limit as 2.
Okay, so if we take 0 and minus, we are taking the fh is equals to first function 0 to 8,
Yes.
and for 0 plus we are taking t greater than 8.
Yeah. So 0 minus means
Okay.
we are tending to 8, but from the negative side of 0.
Oh,
That means the
okay,
numbers
okay.
are less than 8.
Okay, okay.
Okay. Similarly, when you are calculating the limit x tending to 0 plus, you have to take this, and similarly you have to compute this. Okay.
Okay.
Now can you do
Now,
it by yourself?
yes, yes, ma'am.
Okay. This is the same thing, no?
Yes, ma'am. Yes, ma'am.
Okay. Yeah, anything else?
No, ma'am.
What about others? I'm waiting. If you have something to ask, you can just ask. Maybe can discuss one more problem. So suppose you have an example, limit x tending to 0.
Ma'am, can you solve my doubt from PNC?
What?
Permutation and combination.
Permutation and combination is not in Maths 1, right?
It's in stats, but can you solve it?
No. So you should ask it in the stat session, right?
Okay, okay.
Yeah. I can't take stat out. Also, I forgot the formula. So,
Okay, okay. No, no, it's okay.
so yeah, this is an example. Just try to evaluate the limit at 0.
Is it multiplication in between?
No, this is negative sign. Minus.
Okay.
Can you find any limit?
No, I think answer is 0.
0. Okay. So if I put directly 0 instead of x, we will get 0 by 0 form, right?
Yes.
That means we have to use the L'Hopital rule.
Yes, ma'am.
So from here we will get 1. From here we will get 1 over 5. 1 plus x to the power 1 over 5 minus 1 minus 1 by 5. 1 minus x to the power 1 over 5 minus 1, right?
Yes.
So this will be what? This is what? This is basically 1 over 5 into 1 plus x to the power
Minus 4 by 5.
then minus 1 over 1 minus. Okay, so from here we will get plus because minus x. So minus x we have to again do the derivative using the chain rule. So this will be plus, right?
Yes.
Now if I put 0 extending to 0, so if I put 0 we will get 1 over 5 plus 1 over 5, that means 2 over 5, right? Okay, any doubt?
Ma'am, is this positive sign because of double derivative?
Which one? Yeah. So it is because we are using the chain rule, not double derivative. So we are doing the derivative of this function. So for this, the second function, we are using the chain rule. So we have minus x, right? Then we have to again do the derivative of minus x. So we will get positive here.
Got
Yes,
it, ma'am.
I missed this minus sign.
Yeah.
That's why I got 0.
Yeah.
Same here. I got 0, but I forgot
So
one minus
the
x.
silly mistakes are really enemy of the exam. So you just have to like think about it. Okay, don't do the silly mistakes in the exam. In exam, you will get the same type of question, and try to avoid the silly mistakes. Okay. Yeah. Any other doubt?
Can you take 1 or 2 questions from your side from any week 5 to 8?
Yes, ma'am. Any important question?
Okay. The question what I did, it's important. Okay. It's like it's important from exam point of view, so you can follow them. I can maybe take one more example. Suppose we have f of x equals a cos mod x. Okay, suppose this is given and you have to find the relation between a and b.
Ma'am, differentiation of cos mod x is minus sin mod x. Can you tell me?
Sorry, I was on mute. Yeah. So differentiation of
Cos x is minus sin x, but cos mod x is
okay. Differentiation of cos x is minus sin x, and if you have mod x means you have to do the differentiation. So once you have the mod x, like cos of mod x is what?
minus.
It is equals to cos x again, right?
Okay, yes, yeah,
Because cos is a even function, right?
yes.
So you can take it as cos x and do the calculation further.
Okay.
Okay, it can take e power x. Log mod x may be somewhere problematic.
Now the question is plus b e raised to power mod x.
Yeah. Okay, so that means we can rewrite it as a cos x plus b e power mod x. So when x is greater than 0, greater equals to 0, this is a cos x plus b e power x. And if x is less equals to 0, then this is a cos x plus b e power minus x, right? We can break the function in that way. So the function is differentiable at 0. That means that left hand derivative and right hand derivative are equal, right?
Yes.
This, right? Then limit is tending to 0 plus. So what value we will take?
A cos x plus b a
Cos instead of cos, maybe we can take tan here. Otherwise, we will not find the limit. Okay, tan. Okay, replace the cos as tan function. Okay, so what we will get? The right hand limit.
a tan x plus b e raised to power x. Tan h.
This, right?
Yes.
Now, limit is tending to 0 plus a tan h by h plus b limit is tending to 0 plus e power h by h, right? We can split them in this way. By h plus b limit is tending to 0 minus e power minus h by h, right? So limit h tending to 0, tan h by h is 1. We know that, right? So we will get a plus b. What is the limit of this? What is the limit of this?
Ma'am, there will be another, ma'am, shouldn't we include another term like f of 0 in the limit?
Yeah. Sorry, I just forgot it. Thank you for naming. So what is f of 0? That means we will put the 0 here. So we will get b, right?
Minus b. Ma'am.
Minus b. Again minus b here, right? Is it fine now?
Yes.
Okay. So minus 1 we will get and minus 1 here. Is it okay now? Now it is in 0 by 0 form. So we can use the L'Hopital rule, right? So if I use the L'Hopital rule, we will get limit h tending to 0 plus e power h by 1. That means 1, right?
Yes, ma'am.
Yeah. Okay. That means b we will get as limit. And then if h tending to 0 minus, then again we will get is a. And what about this? You're doing something wrong.
Minus b.
So we will get how we are getting minus b from here. So if I just derivative this, we will get minus e power minus h, right? That means if I put 0, so we will get minus 1 and b, that means minus b. So a can be cancelled out from here. Then we will get 2b equals 0. That means b will be equals to 0, right? Is it fine? Is it okay? Any confusion? Any confusion?
Ma'am, e raised to power minus h minus 1 by h is 1, right? That's how you have solved?
Limit is 1. So it is 0 by 0 form, right? So you can use the L'Hopital rule. Then we will get in the next line, we will get limit h tending to 0 plus e power h. Now if you put 0, you will get 1.
Yes.
Similarly, here you will get e power minus h. Now if you put 0, then you will get 1. Minus 1. So it will be minus b, right?
Correct.
Yeah.
Ma'am,
Yes.
excuse me, ma'am.
Yes.
I have sent a similar question in the chat box, a screenshot in
Okay,
from the
one second.
document.
One second. Maybe we have done a mistake because we changed the function to tan x. So when x is a negative, okay, no, it's fine. Yeah. Yes. What was the doubt? Is it clear? Is this thing clear? Is this problem clear? Okay. Yeah.
Ma'am, I had sent a question in the screenshot.
Hmm.
The 10th one.
Yeah. I did this maybe in the last session too. So Yeah, so what is it? Is continuous and differentiable at x equals to 1, then we have to find the value. So if it is continuous, then the right hand limit and left hand limit is equal, and it is equals to f of 1. From where then there we can find m is equals to 0. So the left hand limit will be k plus l, and the value at 1 will be the value at 1 will be k plus l, and then right hand limit will be l plus k plus m. From here we will get m equals to 0, and if it is differentiable, again we will get maybe k minus 2l equals to 0. You have to use the formula of differentiation. So we will get k minus 12 equals to 0. So in a result, if you add them, we will get 0 maybe. Okay. So you have to use the formula of continuity and differentiation. Then you can find the relation between them. Okay.
Understood.
Yeah.
Ma'am, I have shared one question.
Okay. Yeah. For this question, so I have to check the differentiability. Again, we will check the left-hand derivative and right-hand derivative. So what will be the left-hand derivative? Let us start with left-hand derivative. F of h. F of h and left-hand derivative means we will take this one, right?
Yes.
So that means this. Minus 0 at 0, we will get 0, then h, right? Is it fine?
Yes, ma'am.
Okay. So now, what is the ceiling function of h, where h is tending towards 0? It is in the 0 by 0 form, right?
Ma'am, the above one is floor function. What about the second one?
Okay, the second one is actually ceiling function. So the ceiling function means we will take the integer immediately after that number. So when we are taking the floor function, we are taking an integer which is just before that number, and when we will take the ceiling function, that means we will take the integer just after the number, the greatest like the integer which is just after the number.
Okay, ma'am. Right next to it.
Yeah, right next to it. Yes.
So it is floor function plus 1.
Yes.
No, wrong, madam. That will not, because 4.0 still it will be 4 only, no? It
But
will
at
be
integer point we can't say.
Yeah.
At integer point, at integer, okay.
4.0 will be 4.
Yeah. At integer point we can't say, but at what about the non-integer points?
Non-integer part, 4.3 will be 5.
4.3 will be 5. Yes, correct.
Now, what will be the answer of this?
Such type of question, can I draw a graph and tell that it is not differentiable or differentiable?
See, for this function, this function is the last option. That means because you have the ceiling function and floor function at 1 and minus 1, we know that limit doesn't exist, right?
Yeah.
So from here, from there, we can directly first imply that because limit doesn't exist, that means it is not continuous and it's not differentiable, right? That means the second and third option can be discarded, but the fourth option is correct, right? At non-integer point, we know that the floor function and the ceiling function similarly a limit will exist and it will be continuous and also it will be differentiable.
I guess we'll get value 2 in both the cases, right?
Yeah, yes. So 1.5 you are checking means you have to only take the floor function, which is greater the functional value for greater equals to 0. So 1.5 means it doesn't matter whether approaching from negative side or positive side, you have to take the greatest integer function. Okay, so the greatest integer function, what we know that it is differentiable, like it is a nice function, piecewise nice function, right? That means at non-integer points, it will be differentiable. So the fourth option will be correct.
Only fourth option will be correct, madam.
Yes.
Okay, yeah. So fourth option will be correct. At 0, maybe we have to check. So if we check at 0, so when x is tending towards 0, that means something near 0. So the Selling function of this will be in 0 by 0 form, right?
No, directly we can draw. See, for example, when we draw the graph
Yeah.
from -1, I mean 1 to 0, it will be.
So -1, 0, and suppose this is 1. So when it is 1 to 0, like somewhere here, then we will find the floor function. If x is 1 to 0 to 1, that means we will take the floor function of x, that means this, right?
Yes. And at 0, it's defined. So it will
And
be a filled dot.
Yeah, and if at 0, it will be 0. At 0, it will be 0, right?
Yeah, from -1 also, it left
From
hand limit.
-1 to 0, again it will be 0, right?
Yeah, limit will tend to 0.
That means
Yeah,
from
so,
-1 to +1, it will be a straight line basically. So it
yes.
should be differentiable at x equals to 0, right?
Yes, madam.
Yeah.
Ma'am, please repeat. I didn't get.
Okay, so the graph is clear. At from 0 to 1, it is the floor function of some x, which is from 0 to 1. That means we will get the functional value as 0, right?
Yes, ma'am.
Again, from -1 to 0, the ceiling function of something which is -1 to 0, we will get the functional value as 0, right?
Yes, ma'am.
And at 0, the functional value is 0. That means from -1 to 1, we can see the graph is just a straight line, the x-axis from -1 to 1. So it will be differentiable at 0, right?
Yes, ma'am.
Okay. That is.
What about 1.5?
Okay. At 1.5, so 1.5 means it is from 1 to 2, right? Here.
Yes. Yes, ma'am.
It will lie here. That means again it is a straight line from 1 to 2. That means it is a straight line near in a close neighborhood of that point. That means it is a differentiable function. Okay. So the first and fourth option will be the correct one.
How have you discarded the second and third option, 1 and -1?
At 1, we know that the floor function and ceiling functions limit doesn't exist at integer points.
Okay.
Okay. So limit doesn't exist means not continuous means not differentiable. Okay.
Yes, ma'am.
Yeah. Anything else? Any other doubt?
No, ma'am.
Okay. So if you have any other doubt, you just ask. Otherwise, we can end. So I'm waiting for some time. So tomorrow is the exam. Yeah.
I have shared the question. It is from week 5 and 6.
Any special tips you want to share with us, madam, for the quiz 2?
Special tips, I mean, if you are looking for exam point of view, then I would say just follow the type of problems we solved in our revision sessions. So these are important. Otherwise, the most important thing is just try to clear the concept. Like if the concepts are okay, if the approaches are fine, then you will get it solvable. Okay.
Okay, ma'am.
Okay, so we have to find the domain of the composite function. So yesterday we were discussing these things only, right? How can we find this? We can
So first we have to find the
maybe we can do this like we can do this in this process, but here I guess we can do this in simply we can like calculate this because there is no 1 by x and all, so we can directly compute this. So we will get g of 1 minus x power half. So g of 1 minus x power half means 1
1 minus x power half the whole square. Okay, half and square will cancel off. 1 minus 1 will cancel off. It will become plus x.
Yeah. So this will be r, right?
Madam, but 1 minus x, root of 1 minus x, you cannot have x equal to 1, no?
Okay. So first of all, we have to consider the domain of f. That means x 1 minus x should be greater than 0. That means 1 should be greater than x, right?
Yes.
X should be less than 1. That means r minus 1 to infinity, right?
Yes, ma'am.
And again, this interval we can write it as this. So minus infinity to 1 intersection, this means what? Minus 2 to 1, right? This, right? Union minus.
Now, why the minus 2 has
got
come
it.
from
Yes,
where?
ma'am.
Madam, minus 2 from where it has come?
From here.
From
No, no.
intersection 1.
Intersection of this two.
Okay, okay. Our
Minus 2 to 1.
domain
2
is
to
r
1.
minus 1 to infinity only, but that can be written as like this.
Yes, yes, right.
Actually,
So
I
this
got
is
the
an
first
another
option. I was just
Only
confused with the
confusing.
second option.
Yeah, yeah.
Yeah.
So this the intersection we can write is as minus 2 1 close interval union minus infinity to minus 2, right? So this will be what? Minus infinity to 1, this, right?
Okay.
And this is what? This is nothing but this, right? R minus 1 to infinity.
Okay, okay. So such type of domain of composite function finding, we have to go with the procedure, no, madam. Like first
Yeah,
find f of
it is
x domain
always
and range.
best to go with the procedure. Like
First
there
find
is
domain and range for f of x, domain and range for g of x.
Yeah.
Then find out the g of GOF of x.
Yeah.
Then finally you can check up D is a subset or equal subset of A.
Yeah.
Where C is she should be the, you have to adjust C accordingly, like that.
Yes.
Step by step, if you go, then we wouldn't have missed that because directly the GOF is direct x, no? So we'll tell it as R.
Yeah.
But we forgot that 1 minus x power of 1 is not there in the range. I mean,
Correct,
domain.
correct. Yes, yes, correct. So if you calculate and directly compute the domain, there will be some problem like that.
And first option we would have ticked and got 0 marks.
Yeah, yeah, correct. So yeah, this type of thing can happen in this way. So it is always better to follow that way, which I discussed tomorrow. Sorry, yesterday. Okay. It's always better to follow that ABCD thing.
I solved about 4-5 problems of this type. It took little bit more time, whether that question is asking or not. But ultimately, you get the right answer, ma'am.
Yeah. So there is no chance to get a wrong answer if you follow that way.
Yeah.
For sure. Yeah. Okay.
Okay. Thank you very much. Good night.
Yeah. Good night, all of you. So best of luck for your exam tomorrow. Hope it will be nice. Yeah.
Hope it will be easier.
Yeah, it is not that tough. some question may be a bit tricky, but yeah, but there may be some googly type of question. So we just
So 1 or 2 Googly will be there.
maybe. I will not say anything right now, but yeah, it is not that hard. Only what you just have to be concentrated.
Okay.
Okay.
Yeah.
Okay. Thank you. Thank you.
Okay.
Ma'am. Good
Yeah.
night.
Good night.
Thank you.
Okay.
Good night, ma'am.
Yeah.
Thank you, ma'am.
Yeah. Welcome.